obviously. Brief ones. So, okay. So, able to hear and both able to see the video, means the
Yes,
Yes,
ma'am.
presentation?
ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Fine.
ma'am.
Okay. So, I left with the Ohm's law part and the limitations of Ohm's law. So, we just go back to where we just left out. This was our Ohm's law. Okay, so it stated that the current flowing through the electric circuit is directly proportional to the potential difference across the circuit and inversely proportional to the resistance of the circuit provided the temperature remains constant. So mathematically we can write I to be proportional to V by R, that is actually equal to I equals to V by R, provided we take that unity is the value of all the parameters. So if that is considered, and obviously I is the current flowing through the circuit in ampere, V is the voltage applied across the circuit, and R is the resistance of the circuit. So far as this is clear to you all, I also explained about the limitations of the Ohm's law, means this law won't held good for the following things. What are these? That they are not applicable to non-linear devices such as diodes, Zener diodes, voltage regulators, etc. And also it does not hold good for non-metallic conductors such as silicon carbide. And the law obviously is for such conductors is different, and that is actually given by V equals to k into I to the power m, where k and m are the constants. Now I am moving on to the a kind of problem which is very easy actually, the formula which is given here. I would like you all to write down all the formulas that we are going to discuss for today's class. Okay, so just continue doing that, writing in your exercise book or copy or notebook, whatever you have. Just write it down that actually the Ohm's laws mathematical wise it is given by V equals to IR. Okay, so first write down this, that according to Ohm's law I is equals to V by R, or V is equals to IR. I hope everyone is written down. So I'll just move on to the problem statement. Just try to give the values once you are over. It says that the load resistance in a 220 volt, it will be 220 volt circuit is 80 ohm. So determine the load current. Is this visible to everyone? Everyone can get the problem?
Yes,
Yes,
ma'am.
ma'am.
Can you find the load current? The 220, there will be volt. The sign is unit is volt. The load resistance in a 220 volt means that is the voltage. 220 volt circuit is 80 ohm. So determine the load current. This is the basic or the easiest one actually. The voltage is given 220 volt. The resistance is given 80 ohm.
2.75 ampere.
Right.
2.7.
Can I know your name?
2.75 ampere, ma'am.
Yes, yes. Okay.
2.7.
C2.
Fine. Okay, Siddhi. So the easiest one is over. Now let's move on to a bit which is actually more related to other formulas. So this one is the basic ones. I am not going deep into that, and nothing difficult in this one. So 2.75 ampere is the answer. One must write the unit ampere. Unlike here, beside 220, I didn't write V or volt. So that should not be in your case. You should write 2.75 ampere or A, capital A. So next, moving on to some other formulas. I would like you all to write down whatever formulas we are discussing today in today's class. Okay. So the next parameter after Ohm's law that we are going to discuss or study is conductivity or conductance. If anyone is familiar with the term, then okay. If anyone is not familiar, then also I'll discuss it. I hope you are familiar with specific resistance or resistivity as per the Ohm's law. We have from the information of whatever the properties were for resistance, the factors that affect resistance, there was something called rho or the resistivity. Okay, so the specific resistance or resistivity rho of a material represents its opposition to the flow of electric current. However, the reciprocal of rho represents something called conductivity. Means resistivity का inverse है conductivity. The inverse of resistivity 1 by resistivity is actually conductivity, and we call it this reciprocal of rho or reciprocal of resistivity represents the unit that describes the material in terms of its ease of flow of current, ease to flow of the current, electric current. This is known as conductivity of the material. Just the opposite or the reverse of resistivity is conductivity. If resistance, actually what we studied till now, that resistance is the opposition to the flow of current. Conductivity is the ease of flow of current, just the reverse of resistivity or resistance. Okay, so resistance opposite is conductance and the opposite of conductivity is resistivity, or the vice versa. Means for opposition, just the reverse of resistivity is conductivity and reverse of resistance is conductance. Okay, so I hope it is okay with everyone.
Yes, ma'am.
Yes, ma'am.
Ma'am, what
Okay,
is
right.
relation?
Yes, yes,
What,
tell.
what is relation between resistance and resistivity, ma'am?
Resistance is R, right? And
Okay.
resistivity is rho. Okay, means if you had seen the relation earlier, I'm just going to the earlier relation. You see this R is resistance, rho is that which one is written as P, you see, like just like P it is written, but something is different than P. So that one is called as resistivity and R is resistance. So basically R is equals to rho L by A here. Can you see this?
Yes, ma'am.
Okay, so R is the resistance, rho is the resistivity. So R equals to rho L by A. This rho L by A, rho is the resistivity and R is the resistance. Got it? Got my point?
Oh, yes, ma'am.
Okay, now you can just write down this formula also. It will help you. R equals to rho L by A. Okay. So this was about resistance and resistivity, and just the opposite of resistance and resistivity is the conductance or conductivity. Okay, now just like rho, there is conductivity, inverse of conductivity, which is termed as gamma. You see gamma is written as equals to 1 by rho. Is it visible?
Yes, ma'am.
Yes, ma'am.
Okay, so this conductivity gamma, we call this symbol as gamma. Okay, conductivity gamma is equals to 1 by rho. Now, similarly, the reciprocal of resistance or R is termed as G. This is conductance. So, conductance G is equals to 1 by R and conductivity gamma is equals to 1 by rho. Clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay, okay, fine. So now we go to the relation which is very similar to the one with resistance and resistivity. Because in this equation, we have both conductance and conductivity. We see that if G is the reciprocal of R, suppose, then obviously it can be given as ampere by volt. G is equals to ampere by volt, because according to Ohm's law, resistance was what? Equals to V by I, right? R was equals to V by I. So conductance will be I by V or A by V, ampere by volt. Is this clear or not? Just tell me.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Remember that
Once again.
unit
Ma'am,
of
please repeat.
conductance. Yes. Tell anyone.
Ma'am, repeat, ma'am.
Please repeat once again.
Okay, sure. You see, what we saw, the two formulas, I'm just writing down better. You will understand like that, I think. Yes, I'll just write it down. I'm sharing the camera. I don't know whether it will not be so still. Okay, it may be something trembling, but I'll show just with the help of this. Just remember that we saw R is equals to rho L by A, where R was resistance, rho was resistivity. Similarly, conductance or conductivity is given by gamma and conductance is given by G, which is the opposite of R. I'm just writing down. Wait. Is this visible? Is this visible to you all?
Yes, ma'am.
Yes, ma'am.
Okay. I'm writing down, just see it, whether you understand or not. Earlier, what we saw, R is equals to rho L by A, right? Everyone?
Yes, ma'am.
Where R was resistance and this rho was resistivity, right?
Yes, ma'am.
Okay. Now we have something called conductance, which is the 1 by or reciprocal or reverse of rho. So conductivity is given by the symbol called gamma. This is gamma. Okay. Now as you can see, gamma is 1 by this rho, means 1 by rho is gamma. And conductance is given by G, which is equals to 1 by R. Now clear everyone? G or conductance is 1 by R and conductivity is opposite of 1 by of resistivity, 1 by rho. Everyone can write this down, please. Everyone write it down. Written?
Yes, ma'am.
Yes, ma'am.
Okay. So now we can say that according to Ohm's law, R's expression was what? Means we can write R, of according to Ohm's law. According to Ohm's law, we can write V by I. Darshan, please mute
Yes, ma'am.
yourself. If anyone is unmuted, please mute yourself. Okay. You can speak only when you are speaking, you unmute. Otherwise, you mute. Okay. So this can be written, R can be written as V by I. Now, 1 by R can be written as I by V. And this I by V is 1 by R, which is G, right? Because G is basically equals to 1 by R. 1 by R is I by V because according to Ohm's law, it is V by I, right? Now, anyone having any confusion? Please ask.
No, ma'am.
No, ma'am.
No, ma'am.
Someone was
No,
asking,
ma'am.
is it clear? The one who asked about this, is it clear now?
Yes, ma'am.
Okay. So, obviously, you all should write this down, okay? Whatever I am explaining, just the formula part, you should write it down. Because later, I'll be going to problems or exercises, okay? So, this is okay with you all. Now you see R, this R is equals to 1 by G as I wrote here. G equals to 1 by R means R equals to 1 by G. I can write, right? Now, since R is equals to 1 by G, this can be written as rho L by A. R is written as rho L by A. So that rho L by A, this equation here, we can represent this R as here R, which is 1 by G. Now this expression of rho L by A here I can write as rho as 1 by gamma or conductivity. From here we get rho equals to 1 by gamma, right? Rho equals to 1 by gamma. So in place of rho here, I can just write down 1 by gamma L by A and this can be written as L by gamma A. Is it clear?
Yes, ma'am.
Yes, ma'am.
Tell me if anything is not clear.
Ma'am, last step explain once again.
This one, this one.
Yes, ma'am.
Yes. Okay, I am writing this equation again. Okay? That R is equals to rho L by A. If R is equals to rho L by A, then this is also equals to 1 by G because R is equals to 1 by G. Here I have written. If R is equals to 1 by G and rho, this rho is equals to 1 by conductivity or gamma, I can write this as 1 by G equals to rho L by A and replacing rho equals to, I am just writing it down, replacing rho equals to 1 by gamma. Okay. We can write here 1 by gamma into L by A. Sorry. I hope you understand this. This is A. Now you see. Now can you understand? This is this. This one.
Yes, ma'am.
Understood?
Yes, ma'am.
Okay. Understood
Yes, ma'am.
and written down. I want you all to write down all this derivations or not derivations exactly, the expressions from where it is coming. So if 1 by G is equals to L by gamma A, then obviously G is equals to gamma A by L, right? Right or not?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Everyone clear in this step or not? Just tell, otherwise I'll again explain.
Clear, ma'am.
Clear, ma'am.
Clear, ma'am.
Clear, ma'am.
Everyone?
Ma'am.
Anyone? Any confusion?
No, ma'am.
Ma'am.
No, ma'am.
No, ma'am.
Okay. Those who asked about the question, are you all particularly to those people the who raised the query? Is it okay now?
Yes, ma'am.
Yes,
Understood.
ma'am.
Okay, fine, fine, very good. So now I'll just go on to again to the presentation back. Everyone is able to see?
Yes,
Yes,
ma'am.
yes, yes, ma'am. Yes, ma'am.
So this is our expression. Whatever I wrote there, derived, I just wrote it here. You just see whether it is understood and it is okay or not now.
Okay, ma'am.
Okay.
Okay, ma'am.
Now the
Okay, ma'am.
unit conductance. Now, okay. Now the unit of conductance is Siemens. Something called Siemens. See, the unit of resistance is ohm, right? Just the opposite of ohm, which is G, or which is R. R is 1 by R is equals to G, and G is equals to 1 by R, and R is equals to 1 by G. Just the opposite. So that G is equals to Siemens. The unit is Siemens. Okay. So now I go to the next thing. I'll give you another problem now. Let me see. Okay, before the problem, there is another something called power and energy. Everyone can see the slide.
Yes, ma'am.
Yes,
Okay.
ma'am.
So everyone is familiar with work, power, and energy, right? So for work, power, and energy, whatever we have learned that power can be defined as the rate of change of energy or work, and the unit is watt or joule per second, right? Power, everyone knows power P.
Yes, ma'am.
Just write the expression of power now. Everyone write down this expression of power. That power is actually rate of change of work or rate of change of energy. So if rate of change of work or energy is given, obviously it is given by dw by dt differential. We write it down normally as W by T, right? Now we are taking differential terms because everyone we will see that differential amount of work is done. So the rate of change is like that. So dW by dt is our power. Anyone who cannot understand, please raise question. Is it visible to you all?
Yes, ma'am.
Yes, ma'am.
Any questions, anyone? Okay, so I'll just move further. Just write this down that P is equals to dW dt, and that is equals to, we can write it down as dW by dQ and multiplied by dQ by dt. We can break it down like that, right? Because this dt is in the denominator, in the numerator is dw. So in the numerator dw is there, and we create a denominator dq, which is charge, and multiplied by dq by dt. If we do, then we get this dq by dt. We know that charge by time is actually current. So we just replace that dq by dt with I. And we also know that a differential charge dq, if given a differential energy dw, then it is the potential. Means dw by dq is the potential of the charge. Okay. So potential is represented by V. We give it as V. Anyone has any questions, please raise.
No, ma'am.
If the concept is not clear for anyone, you can please raise a question. Okay. So, is the expression okay for you all? Why
Yes, ma'am.
dw dt we wrote as dw by dq and dq by dt. We just broke up the dw dt into dw dq multiplied by dq by dt. Now dw by dq becomes v and dq by dt charge by time becomes current. So basically power is equals to voltage into current. Hope it is clear for you all.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now moving
Yes,
on to
ma'am.
energy.
Yes, ma'am.
Okay. Now moving on to the expression of energy. Energy is again given by, means if we have the power as P equals to dw dt, then if we integrate that work or that energy, then we get W equals to integration of VI into dt. Everyone please write the expressions. Just the expressions. Is the concept of energy clear to you all?
Yes, ma'am. Yes, ma'am.
Okay. So energy is defined mainly as the capacity of doing work and its unit is watt second. We can also write it as watt hour, watt minute, whatever the unit is. So watt second is the SI unit, derived unit, SI unit. So energy is given by this term W equals to integration of VI into dt. I hope this slide is clear to all of you.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
So this slide along with the previous slide, this one. Now I'll give the problem on these two, and that will also involve Ohm's law. See, as per whatever we have got, we can write this as P equals to VI, power is equals to voltage into current. Again, using Ohm's law, we can write V equals to IR, current into resistance. So, if we replace the V equals to IR into the equation P equals to VI, then we get, just replace this V with IR. So IR into I is power. So I square R is the power in watt. Similarly, using the next formula of Ohm's law, which is I equals to V by R, we just replace V by R again in this P equals to VI. Then we get P equals to V into V by R, which is V square by R in watts again. Everyone please write this down.
ती पट्टी आणून दे जरा सवर
Someone please mute. Someone please mute.
माझ्याकडे आहे की दुसरी
Who is not unmute? Who has unmuted?
सांगताना तेव्हा हसायचं
Your-
होतात कर की.
Kadambari, please mute yourself. Have you all written this? Please write this down. Is this understood by all?
Yes, ma'am. Yes, ma'am.
So I'm giving a problem. Let me see whether you are able to do it or not. Okay. Everyone written right? I'm just removing the slide.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So this is the problem. This is the next problem. You can write it down or you can just do the problem. It says that determine the conductance of a short circuit on 120 volt which results in a short circuit current of 500 ampere. Very simple. Voltage is given, current is given. You have to find the conductance. Conductance is given by G, right? And what is its relation with voltage and current?
I by V.
Right. So I is given, V is given.
Ma'am, 4.16.
Right.
4.1
4.16. Yes.
Siemens.
4.16 Siemens. Right. Right. Siemens should be Siemens. Siemens is the unit. So 4.16 Siemens. Very good. Everyone can understood or not?
Yes, ma'am.
Yes, ma'am.
Yes,
Anyone
ma'am.
having any question why it is not done? Anyone having any question? Please do.
No, ma'am.
You can raise a question if you don't understand. Please, anyone. So everyone understood this is also very simple that conductance G is equals to current by voltage or I by V. Now conductance is what is required means they have asked what is the conductance. You have I means current, you have V means voltage. So you just give G equals to I by V and you get 4.16 which is the answer. Okay, so next problem that I am going is this one. Determine the power rating of a device which is rated as 15 ampere and 250 volts. Power rating is wanted. They have required the power rating. And current is given, voltage is given. V is given, I is given. You need to find P, power. Yes?
Ma'am,
Yes, yes.
375.
3,750
3,750.
And what is the unit?
3750 volt.
Unit,
Watt.
unit.
Watt. Watt.
Watts.
Right.
Watt.
Absolutely, absolutely. Okay, fine. So this till this it was very simple. Now I am giving you something which I'll just tell you, but you will do it for yourself. Okay. This is the problem. A resistor is rated for 10 kilo ohm, 1 watt. Determine its maximum voltage and current ratings. Let me see if you can do it. I will give you the hints. See, resistance R is given and P is given, watt. They have asked about the maximum voltage and current rating.
P is equals to V square by R.
Right, right. So V equals to
Ma'am, V is equal to 10 to the power of minus 4 volt.
minus 4. No, 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 no. Small mistake, small mistake.
Oh, sorry.
Anyone?
Ma'am, V is equal to 100.
Right. V equals to 100 volt. Now find the current one. The expression of current you have P equals to I square R.
I is equal to 0.01 ampere.
I equals to current equals to 0.01 ampere, right?
Yes, ma'am.
Very good. Now everyone say,
Yes,
did
ma'am.
you have this answer or not? Understood or not?
Yes, ma'am.
Yes, ma'am.
Anyone who did not? To everyone I am asking. I am not taking class only for the good students. People who do not answer, for them also. Did you get it? Do you understand? Is it okay for everyone? Is it okay for everyone? Anyone? Any question?
No, ma'am.
So today I leave my class with this because time is also over, as well as other part of the chapter is also left. Till now, whatever the problems I gave, you just look into that. I'll send the slides as well as the notes. So better you just go through it, because your next class time has already come. You have to join the next class if it is there. So now I'll just leave. The timing of the class is over. So roll call is done. So every day I'll do the roll call in this way only. Okay. So everyone who did took the notes and did write the formulas, and as well as the problems, who did understand, it's good for you all. And for the next class I'll move on to something which is more about the circuit elements, electrical circuits, series and parallel circuits. Okay. So there we will require these formulas as well as some other basic concepts of series and parallel connections. Now, for now, I'm just ending the class here. Thank you everyone for joining. I'll give the
Thank
PDF
you, ma'am.
note. Yes.
Thank
You
you,
may
ma'am.
leave.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you.
Thank you, ma'am.
I'm
Thank you, ma'am.
also leaving. Yeah.